Um, and thanks Ben and Nihar, because that was awesome. It's nice to see how even just in a couple months since I last saw AutoML, how much better it's gotten. And it's fantastic. So I wanted to actually just start by piggybacking right off of where they were. And let me share my screen to give some more technically content. So one of the things about, because I saw in the chat, Ken was saying something about playing with the data science tiles and the difference between high code and low code. And I think Domo does a really good job at now giving tools like the Jupyter Notebook, where you can do that high code piece, and the scripting tiles, where you can then take that high code and put it into production, but also the low code of AutoML and the scripting tiles. Now, one of the things that I found with the scripting tiles as I've used them is that they don't give a lot of the information that you need to really see how good your model is. And but the nice thing is you can do a lot of that with beast mode. So when you use those scripting tiles, the data science, or sorry, not the scripting tiles, the data science tiles, most of them just generate a prediction. And those are supervised machine learning methods like classification and regression. What you get is a data set with a new column at the end called prediction. But it's hard to know how good that thing is. So I put together just a couple of beast modes in these cards that you could actually use to evaluate and see how good your models are. And they're really not that hard. So if I come into this one, I was just trying to predict, where traffic is coming from. And you'll laugh when you see my beast mode because it's bad. This is my prediction. It's an organic visit. I'm just predicting. And this is something that actually you can check your models a lot with this. If you're doing a classification model and you've got really imbalanced data where you've got a whole bunch of one category and very little of the other categories, the models by almost always will just say, well, I can get the best accuracy by just saying the same thing every time. And that's what this chart shows. So mimicking what the computers do. And so you can see I just pick organic visit for everything. It's 100% accurate. The math is not that hard to figure these out. All I'm doing here is a case statement that says when market channel equals, this is essentially my prediction, organic visit, then 1, sum that over all of the market channels. This is the accuracy measurement. Did what I predict actually match what was expected divided by how many things there are? And the nice thing about doing this in a beast mode is that when you're doing the analysis afterwards, like Ben Shine was talking about, putting that human in the mix, you can now start to add filters and build a dashboard where you can dig into, it's like, okay, well, what's going on here? Is it like, am I seeing something like this where the model is just, wrong because it's picking the one thing, or which then allows me to figure out, I was like, okay, how do I need to change the data? How do I need to change the structure so that I can balance these things out? You can use filters to then start digging into like, well, what are the other factors? If I change some of the factors, some of the other pieces in the model and drill down, can I find a spot where this is really accurate versus not? And so using beast modes in cards to extend the discussion and help the models get better is really, really helpful, even if you are using something on the low code side. And you can do the same thing with regression models. And so when you're doing regression, you're always looking at the error, and most of the time you're looking at the error. And one of the main things that you'll want to look at, one of the very common metrics, is called the root mean squared error, the RMSE. And this actually came up in actually the Slack channel the other day. And this is essentially the code to find the root mean squared error. So if profit is what I'm trying to predict, and I just picked a value, 170 is my prediction, we take the difference of that, square it, take the average of the squares, and then take the square root, and that's our error. And we can then see, there are certain months where my model, as dumb as it is performing better or worse. Another one that we can use is called mean absolute error. Actually, I'm going to go to the next one because we can actually compare these. You can see my MAE versus my RMSE, and they can provide very different results. MAE is actually just a simpler formula. It's the absolute value of the error, the difference between my predicted and my actual value. Take the absolute value and then take the mean of that, and you'll get different scores. And one of the nice things about having so many different metrics to evaluate models is that each one tells you a little bit of a different thing, so that you can kind of figure out how to then move forward. Root mean squared errors, since you're squaring things, outliers have a huge impact. Because if you think like if most of the error is around, like, let's say the error is about 2. If you just took the average error, it would be 2. But if you've got a handful of cases where all of a sudden you're off by orders of magnitude more, so you're off by 2,000, and then you square those, the 2s become 4s, the 2,000s become this astronomical number, and then you average those, and those outliers are gonna pull that average really high up. And that's what you're seeing here with the root mean squared error, is those outliers are then pulling the error values up a ton, just because they're outliers. And that can be really, really helpful in understanding that you've got these weird outliers, and then maybe you need to go back and think, is my model any good at predicting these outliers? Probably not. Should I remove them? Should I try and focus on just the main things, or do I want to keep them in because they're actually part of the real data? The MAE, since it doesn't have those squares in them, it's not squaring or square rooting anything, is a much more robust thing. So the outliers don't have nearly the impact. So one of the things I usually do when I build my models is I actually run both of these and compare them, so I can see what sort of influence the outliers are having in general on my model. When you go to classification models, again, I showed an accuracy measurement. There are other measures that do a similar sort of thing that help you kind of figure out where your error is. Is it with outliers? Are you doing really bad in most categories and only good in some? And by balancing all of those out, you can start to evaluate how the model is working, and what maybe you could do to make it better. And again, this data, my models are stupid. I'm just picking a value to do this. And if you think about your own businesses and the things you're trying to predict, you probably have a mental model in your own head on various things that will impact the data, or impact the model, that will make a good prediction. And so one of the things that I almost always do, again, starting on trying to make the best model possible, and Ben Ainscough talked about this, is the domain expert that he talked about at Domo. He understood the data, and he had a model in his head on how things work. And by putting that model out into the data, generating the model with feature engineering, he was then able to get a much better model.
John, can I jump in real quick
do.
and try to help illustrate that a little bit? How do I share my screen?
I'll stop.
All right, I'm going to do this. So I've given this example before with a couple of people, but I was having this conversation with someone where they're like, hey, Jay, is Domo any good at forecasting? And I like blinked twice and I'm like, yeah, I guess. And they said, okay, well, what can Domo do? And I said, well, it can do everything. Give me a different question. And they, well, what can it do? And I said, well, I don't know. Do the naive forecast. What's the naive forecast? The naive forecast says, if I'm trying to predict the data, the amount tomorrow, it's going to be the same as today, right? So today it's 52. I'm going to predict that tomorrow it's going to be 50. That's supposed to say 52. Oh, I have a multiplier on it. It's going to be the same value as it was yesterday. That's the naive forecast. And the guy looked at me and I think he was a little bit unimpressed with my forecast model. He was like, I want something cooler. Like, can you give me 3-day rolling average or the same value 12 weeks ago? And I was like, okay, well, here's the thing about like asking for something to do something out of the box. And I think this underscores what Ben and John were talking about when they were saying, talk to the business. If your data looks like this, that's one story. But if your data looks like this, and you know that about your company, then you know that, for example, on the first week of every month, I do business with Walmart or some big box supplier that generates a lot of demand, right? And if you know that about your company, then the night forecast, this option doesn't make sense. Look at this other example here. January, February, March, April, May. May. Spike, 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 spike. And then September. What do you know about my company? My company like works with spring breakers who, you know, have a lot of demand in the summer. And then as soon as we go back to school, I stop doing business, right? Asking a model to like just work out of the box, yeah, it can, but there's so much value in knowing and understanding your business when you come to this conversation. One last little thought that I wanted to bring to the table as well. I don't know about you guys, but I do find it super impressive that John, if I asked him what's the difference between MSE versus MAPE versus all of these different error calculation methods. Metrics. That's the word. I don't even know the word. John would be able to tell me what is better about each of them. But one thought I had is like, okay, even if I had a good answer, like even if I had a great forecast, what do you do with that next, right? How do you work that into a business problem or talk business value like Brett was talking about on Monday? So I went with this idea of like, okay, what if we're running a retail company that has a cost for carrying inventory and has a higher cost if they run out of stock? And so what if you like built a little spreadsheet that says, hey, if I run out of, let's ignore these columns. If I run out of inventory, then I want to take the amount that I ran out of and then multiply it by 100. And if I'm carrying inventory, then I multiply it by 10 per unit. At the end of the year, or at the end of the thing, how much was my cost? 76,000. Okay, that's terrible. What if we can massage this number? What if this number was, let's say 5 and 30? Okay, still not good. All right, taking this naive forecast method. All right, what if I do like 1.01? Does that make it better? Okay, what about 1.02? Okay, I promise I'm going somewhere with this. I think, you know, having a really cool, powerful data model built into Domo is wicked, but the ability to do like a little what if analysis, please Domo, please work, please work. This is the inline editor we're looking at here. This what if analysis is the same thing I just showed you in Excel, but powered by views, which is why you should use views, because then you don't have to run ETLs and it updates instantaneously. Refresh my page. This number is going to go to 1550. So now I can do my what if analysis in Domo. My thought here is like data science and having John build me a really cool, powerful model. That's only a small part of the conversation. The rest of the conversation is what do you do with that forecast after you have it? Okay, sorry. Don't want to derail you too long.
No, that was perfect. And I actually, on those exact same lines, can I share my screen? So when Andrew and I started CrystalBallers, it was for exactly this purpose, to do what if analysis. And this is ugly and it only shows a number right now, but this is an app that we've been working on where you can, if you have the really fancy model, just like Jay was doing, it doesn't matter. A lot of this is trying to figure out what is the next best, what's the decision that we need to make. For that, you need to play around. And that's why what if analysis is so cool. And so this takes some employee churn data, and this is the probability that someone's going to leave. And then you can start playing with it. Like how big of an impact does distance from home make? How does that compare with how old they are? So the older people are, according to this model, the less likely they are to churn. The farther they are from home, the more likely they are. And you can just start going down and playing with, all of these different factors that are then being running against a model, so that you can see that, so that you can try and figure out what is the decision. And one of the things Andrew and I have tried to do, and this is kind of the theme we found with all of our apps, like the IDEA app that he posted yesterday. Yesterday? 2 days ago. Anyway, the idea of everyone has hypotheses, everybody needs to make decisions. How can we make the decisions more rigorous? And how can we make them, how can we help people think like scientists? Of management is an experiment. Like you have limited resources, you have ideas on how things work, and you need to be able to try different experiments to find the way to improve. And that could be a process improvement, it could be a data collection improvement, it could be, there's so many different things, but then you need to be able to measure it. And if you can take the mental model that you have, put that with some rigor into data, and then use that to make a prediction, then you can test the prediction, see if you were right or not. And that then can inform what is the next step. So I've seen at many companies where I've been, people going through and saying, this is the thing we need to do. There's a new sales strategy we need to do, or a new marketing strategy, or new whatever. And everyone gets really excited about it, or some people less excited, but they go out and they do their thing. And then you never hear about it again. Maybe that strategy goes on for a year, maybe it's a couple of years, but very rarely do people go back and say, well, what was the impact? How much did this actually help? And sometimes I've seen it where, everyone gets super excited about one thing and then it kind of dies. And then, there's a leadership change, and like 4 years later, they try the exact same thing. But no one has gone back to do the analysis of, did this work? Is this any good? And so thinking about the end in mind, and this is why I love supervised models, is it forces you to say, what is it that we're trying to predict? Do we actually have data for this? And going through thinking about all the different factors and mapping them out, which is something I did on the data science consulting team a lot, we would always find holes, structural holes of people saying, I think this matters. You're like, great, where's the data? And they're like, oh, we don't collect it. Like, okay, well, if this is so important and you're not collecting it, then we've got a bigger problem. You've got a structural hole in your data fabric. So you need to go figure out, how are we going to collect that data? And then once you get that, oftentimes just by having that data and doing basic analytics, you can see improvements in your business. And then it will also help improve the model when you get there. The problem is those conversations can take a lot of time. But data science feels so much, it's very buzzwordy, it's very cool, and I love it. It often feels like the carrot to get budget to go and do foundational data work. It then helps the entire business work better.
Stuff you should already be doing.
But it's hard. Like it takes
change everyone's job title too when everyone gets raises, right? They
exactly.
Change everyone to data scientist once I left. The data science team at Target got changed to like the AI team, and the analytics team got changed to data scientist, right? It's like, who cares? Just do the work.
Yeah. No, it cracks me up. In all the things I've been reading recently, I'm seeing this shift of data science is no longer the model building stuff. It's the data engineering piece. It's like, it's just getting the data. Those are now data scientists, and the people who build models, they're now ML engineers, machine learning engineers.
So I wanted to give a real life example of this particular idea. One of my favorite data scientists, she highlighted a specific example, and I'm going to quote her rather than talk about any of our specific customers. But the example that she used was that she was working on a student churn model with a college, and they had collected all this data, and they were like, here's our data set, just go build models, right? She said, well, hold on, let me talk to some of your employees, some of the people that really understand why students leave, or who might have these mental models for the why. And so as she was talking to one of the administrators, he said, well, her question was, what do you think affects why students might leave, or what data could we collect that might predict whether students might leave or not? And he said, well, I think the number of steps from their dorm or wherever they're living to their first class will, that probably is predictive, or that probably influences whether students have a good experience. Like, I think that's something. Well, of course, nobody had ever collected that data, right? Nobody had ever gone and counted the number of steps from each dorm or from each, large living facility to these different buildings that the students attended. It wasn't hard data to collect. They took a student employee and hired them for the day, maybe for 2 days, and they just collected that data, and then they could use it, which they did, and it was predictive. Now, what's interesting about that is not only that it made their model better, but it actually improved all the students' lives going forward, right? If I'm applying to that college now and I declare myself as a electrical engineering major, they can proactively recommend, hey, why don't you go look at these places to live? Because the building you're going to be going to all the time is right here, and that will shorten your commute, right? Your walk. That makes my life better. It makes my relative chance to churn lower for the school. It just improves everything. And it took that data scientist going and talking to that administrator who understood the experience that these students are having and understood the problem to really factor that in. So that's just one real life example of that process from beginning to end.
I really appreciate in this conversation that, we're talking about data science, we're talking about how awesome Domo is as a platform. But one thing that keeps on coming up in this conversation is that we always have to go back to the business, that we have to talk to the people who know the data, who understand the data, people who understand, well, the students, for example. And, how fast is my data pipe? Nihar's still here. How fast is my data pipeline? How fast is my ETL? How easy is it to upload the data set into Domo? Can I use partitioning or upsert? Like, these are not the important issues. The important things that allow us to really deliver value back to the business is how close IT or the data analysts can operate with the business stakeholders, not just for developing the solution, but, once Andrew figured out, oh, this is how many footsteps we need to take, right? We can work with the registrar's office and build alerts on data sets to make sure that we're keeping students close to their classes and things like this. So it's really cool to think about. We get so caught up in the features that Domo has, when in reality, it's all about integrating process and people and the business together. That said, I know it's almost near the end of the call, but I wanted to give those of you who are hardcore, want to look at some code, give you a little bit of candy. In the Domo Dojo, I set up a little ETL that's actually based off of work that I'm doing with the client right now. They had data coming in from Salesforce. They had customer data coming in from all of their point of sale systems. And they wanted to have one data set that allowed them to say, this customer in Salesforce is the same as this customer in this other data set. How do we know that they're the same without doing manual inspection? And I said, oh yeah, just use fuzzy matching. I'm like, what's fuzzy matching? Google it. Really simple script here. Really simple script here. What it does is I have a data set of, in this example, it's the names of booking room types on booking.com. And in this data set, which I'm going to call my master data set, is the name of room types on Expedia.com. And we want to be able to say these two things are the same. So I need to do a fuzzy matching to say that when I say deluxe 1 king bed in Expedia, I'm talking about XYZ, a deluxe king room in booking types. So I did a little bit of magic, and the output looks like this. So this is the same as that, that's the same as that, that's the same as that. And with visual inspection, you get a good feeling for, yeah, that looks about right, yeah? Is everybody nodding their head yes? Oh, I forget, you're not all unmuted.
Yep, totally makes sense.
Awesome, thank you. But the challenge is that we have to keep in mind that data science, although a lot of it is automated, especially for things like this classification. Is this classification? I think this is classification. For this classification exercise, I do want to get the user to confirm, yeah, that and that are the same thing, or no, it's not. And so we did a V2 of this ETL. As a recursive data flow. Thank God Nihar's not here. Okay, so we still have the same kind of Python script running along the top, but the difference is now I'm going to capture the history of all of the responses where you said, yes, this is a good match, or no, this is not a good match. And so that data set will look something like this. I have new data that came in. And this time, instead of only returning one match, I'm going to return the 5 closest matches. And your job is to accept which one is the right one. And once you accept it, well, I'll remember that forever. And also, if you say this is not the same as that, I'll also remember that for forever. But my point is like we're creating this like business process where we're capturing the input after you run our recursive data flow here. And so that output will look something like this, where I've confirmed that these are matches, and now I get to go through the process of confirming the rest of these matches. In my dream of dreams, right, I don't want to reprocess the entire data set every day. I would only process the new stuff that showed up. And maybe I integrate this in a really nice little custom app experience, or maybe I do this in the inline editor that I showed very quickly. But the last thing I wanted to say on this is this idea that there's this business process and human interaction that is also going into this data science magic. And in case you really, really missed it, I've got a data flow that's outputting a web form. And we're going to talk about how to do that, not today. Okay, I'm done. We've reached the top. John, go.
Oh, I was just going to say something else that might be of considerable interest to this group. I did something very similar, and we were looking for we were looking across all the column names of the data sets in Domo to try and find PII.
Oh, somebody asked about that.
Anyway, so very similar libraries, very similar sorts of feedback loops and other sorts of things. But that's some of the power that you can get with this. And yeah, I didn't look super close to your code, but it's a very similar concept and idea of, we said, look, if it's names, if it's a social security number or anything else, yeah, so here's a list of things to look for and pull out those fields so that then we can find the data sets, then trace them back and make any changes in our source systems.
Which is, and this came up yesterday too, right? Like it comes back to like, okay, how am I empowering more people? I'm sort of creating a mess, but if I can then use data science to help rein in or detect where that mess is getting dangerous, right? It's sort of foundational to the whole proposition of how we change how people are using data, right? But again, if all of that required me to go get approval for specialized data science projects and only find someone who knew Python, whatever, right? Like it starts breaking down those walls of how you empower people, but do it responsibly. So yeah, that's I love that example, John. I've talked to some of the folks doing that too, and it's pretty cool.
Okay. All right. We've reached the end of the conference today. Tomorrow we are going to talk about the Java CLI. We're going to see some examples of data pipeline automation using PyDomo. Darren Thane, the CTO, is going to be here with Ken from the labs team to talk to us a little bit about customer stories. So that should be another day that the folks who are interested in like automating Domo outside of the UI, that's really where we're going to focus the conversation. I'm happy to stay on and answer any questions that kind of come in, but if you've got to go, I totally appreciate, people have jobs. Anonymous attendee asked if there are market basket analysis features in Domo. There's no button in Domo for market analysis, basket analysis stuff. But if you understand like how that works, you can definitely use SQL or Magic ETL to create a data flow that will give you tools for conducting that analysis.
Jay, I feel like you have some good YouTubes on it too, right? So
I don't think I've done one on market basket analysis yet, but I should.
I think it was another one, maybe it was something else. Composition, I don't know, whatever it is. But yeah, I think look, that's part of the challenge. Domo is great because it's flexible, and we certainly work on quick starts and other things. But ultimately, the power is that you can, because I think when you're finally, yes, you can go find a tool that's bespoke to market basket analysis, but then you're going to be very locked into their approach to it, their data model, all those things. And then when you want to show that next to other, so I'll get off my salesy soapbox, but you get the idea. So.
Ian Congdon points out that you can do that in R using the a priori algorithm, which you can run as we have an R library that you can use, or so you can use APIs to get the data, run it locally on your computer, push it back up into Domo, or as we very quickly demonstrated in Domo, you could create a Python script or an R script that will implement that a priori method. You can also do it into the Domo Jupyter notebooks, which were demonstrated by John on Monday. So there's a couple places in Domo where you can actually implement the code, but no, there's no button per se, market basket analysis.